Hello, everybody, and welcome to another E5 podcast. It's another very late or early, depending where you're on the world. I am Paul Meanan, your host for today's shenanigans, and I'm joined once again by my tag team partners and guests. Introduce yourself, chaps.
Hello, I'm JW.
It's Dave Watts here, Sparking Ninja.
David Betteridge.
And our latest guest.
Oh, Krish Theobald.
Krish, all the way from India, returning the favour. So for those listening, if you go onto the National Federation of Engineers YouTube channel, which I have to give them their props because there's some really bloody good videos on that, including Krish's RCD webinar, which I think I just jumped in at the end. But I did a webinar for the team over there on the National Electrical Code of India and kind of took everyone in India on a whistle-stop tour of various standards that we look at and we know and we love or hate. And it was really cool. So I thought, well, Krish, let's get Krish on and we can have a good old-fashioned chit-chat, as we say. Although, what time is it where you are at the moment as we're currently speaking?
It's currently 2:47 a.m. So when we finish up, that'll be time for breakfast.
You part-timer, book half a shift. I don't know. What's it like? Anyway, right. So there is no plan for today. What we were going to do is just have one of them good old-fashioned mishmash chats. But Krish, one of the things I was going to kind of turn it over to everyone in the room. We were going to talk about design because I have designed software, and I'll be honest with you, I am definitely going on Dave's 2396 course at some point soon because I have a 2400 design course from 20 years ago, and I'm rusty as hell. So who wants to start off talking about design? Krish, over to you as your guest.
Yes, I'm happy to go first. Thank you.
Go for it.
So, in every electrical installation has, three stages, you can say. There's a design, there's a erection, and there's a verification. There's obviously maintenance at the end, so design being the most important one because you have to choose everything correctly because there's nothing worse than choosing everything wrong, having it in place, and then saying, oops, we've got the wrong cable, oops, we've got the wrong circuit breaker. And we know that happens a lot, especially in domestics when people tend to wing things. And yeah, so that's a pretty crude and rudimentary way of looking at design, but yeah.
Okay. So do you find in India the design challenges are any different because you have knowledge and experience in the UK because you have UK qualifications as well? You've came over to the UK to do various training courses. You've got a really good applied understanding of 7671. Do you find there to be, I mean, for those listening, this is an open-ended question, but it stimulates a debate. Do you find in India there is less or more design, or it's more stringent, or it's less stringent?
I think it's there's definitely design happening on larger projects. I mean, I put it this way to you: you won't see design happening on a residential project like an apartment. I mean, but you wouldn't see that in the UK either. Am I right in understanding that?
Maybe for like kitchen fit outs, nice ones, you know, where you're spending a big bit of money, but otherwise not really.
Yeah.
I mean, yeah. So it's not that let's say you buy a new because at home at my house recently, I bought 3 13-kilowatt showers. So because we have 3-phase everywhere. So then I put it on electrical OM and I did the design and I figured out that with the grouping factors and correction factors, I needed a 6 square mil cable. So yeah, but there is design done on larger projects, but the way we do design, unfortunately, is not standardized. And this is one of the more interesting subjects because, for example, in the UK, you have where you take measured ZS at 0.8 of the maximum ZS, right?
Mm-hmm. Yep.
In some European countries, they take measured ZS as 2/3 of the actual ZS.
Is that because they're at different climatic ambient temperatures, or is that just a random thing?
I believe the reason is because, in 7671 also in chapter 43, there are limiting temperatures and there are a maximum operating temperature. So in 43 talks about limiting temperatures, the one used for the adiabatic equation.
Mm-hmm.
So I believe the assumption there is that the cables under fault conditions can reach limiting temperatures. So there's a corresponding increase in conductor resistance.
Okay. But this is still, but that is still under operational characteristics, not any fault characteristics or anything like that, right?
What do you mean?
So it's just under load, it's not under fault condition.
Yeah, but I think the logic, then again, the logic in those countries or like is that when the fault happens, before the device interrupts it, the cable may get as hot as its limiting temperature, right?
Mm-hmm.
So when it's at that limiting temperature, there's a corresponding increase in resistance. So that's why you take that 2/3 factor. But in countries like India, what we like to say is that it's a safety factor because you don't want to cut it as tight.
Okay.
So
that's interesting.
That's something interesting. And then the other interesting thing is in the UK, and I know I was introduced but to this by, I think we're going with Mr. Betterman, is it?
Mr. Betterman, Mr. B.
Yes. So he was telling me about how on the what course was that, David? The one you did on electrical vehicle. Did you do the course on EV large scale electrical vehicle charging?
No, I've done the commercial lower end one.
So did you have to do the calculation where you have to take into account the conductor reactance?
Yeah, with the magnetic effect.
Yeah, so that's from from PDCLC DR 50480.
Yeah, that's in the large scale course. I think they've studied that, but he's not finished that because he was on that course with me, and then he paused the course because my mother passed away. But you've studied that one. So yeah, we have the magnetic effect. That's a 1.1 multiplier, which I believe just increases the protective conductor by 10% of itself or something. So we had a 1.1 times R2 times rating factor for temperature, which 1.225 for steel, 1.2 for copper, things like that. But the 1.1 magnetic effect is quite an interesting number because it's in Best Practice Guide 6, I think. The guidance note 6, and it's in the IT Design Guide. But I've tried to kind of figure out exactly where it originates from, not with much luck.
No, it originates from CLCTR 50480. So that's the standard for selection of conductor cross-sectional area. And in the GB adoption, there's a national annex that talks about this. But the more interesting one is the reactance values, because we all know impedance is made up of a resistive component and a reactive component, right?
Mm-hmm.
So the more interesting one is the reactive component. So in CLCTR, in PDCLCTR 50480, it prescribes a value of 0.3 milliohms per meter for steel wire armor cables.
Yeah, just the armor.
Yeah, just the. I'm not entirely sure if it's just the armor or if I think right. Just the armor.
0.3 if it's just the armor as a protected conductor, and 0.4 if you're using the armor and another conductor in parallel.
Yeah, I'll have to open the standard and check, but yeah, but the more yes, Paul, sorry.
Yeah, sorry, I just wanted to say that you boys are doing a dramatically amazing job. One, making me feel thick, two, making me feel stupid, and three, making me want to attend large-scale EV and design courses as soon as possible. Don't you dare smirk, John. I can see you smirking. What are you talking about?
Krish is right. It's data that's used in this technical. Was it TC5? Oh gosh, I need it in front of me.
Right. So basically, what I'm hearing, and forgive me because I'm going to put this in my usually stupid, idiotic way. So rather than us running like the 75 or 80% rule of thumb that we use, there is a 2/3 rule of thumb that they use in India, which they believe is a better way of derating the ZS and ensuring compliance to the circuit. Am I right in that?
It's not just a rule of thumb, because this 2/3 value, it also has its original. Actually two places where I've seen it. One, so in the UK, you have I don't remember the terminology. Let me just open up my copy of 7671. But you have its chapters, right?
Yeah,
That's how you refer to them. I used to do that when I did my 2391 and 2396, but now it's all changed. So part 6, you have part 6, and part 6 talks about verification, right?
Mhm.
And so in your guidance notes and on-site guides is the 0.8 factor mentioned. But there's actually an annex in to part 6 in the IEC standard, which is not there in BS 7671. And that prescribes a 2/3 factor between measured values and an absolute, and well, the maximum, I need to check again, but basically it's to correct from measured values, and it's for that temperature correction. So
when you say the annex, are you referring to the 60364 level?
yes, so on the
Okay.
60364 level, there's a annex to 60364 part 6. And that annex has a 2/3 factor mentioned. In fact,
so can I put my obligatory UK hat on there and say that whilst JPEL, our wonderful JPEL committee, who I currently love for being the filter of all of these things, that when we talk about the IEC standards for those listening, there's a lot more information in those HD 60364 standards. A lot more. We cherry pick and take what we need. But yeah, obviously Krish has a vast level of knowledge of all these 60364, but this 2/3 stuff, I've heard of this before, Dave.
It makes sense to me. I mean, IEC is an international level. I mean, we in the UK use this 80% purely because we consider them to be measured at 20 degrees, operating temperatures up to 70 degrees, and those are specific climatic conditions, which again may not be representative around the world in other places. And the fact that Chris is alluding to the fact it also considers the increase in temperature for part of the fault. Because for us, it's just 70 as a limited operating temperature. We don't think about the fault until it goes into fault current protection, which is under, where we have the TK squared S squared, where we go up to 160 degrees for 70 degrees. So it's interesting. It's interesting. I'd like to kind of read up more on this.
So I mean, you can have a look at CLCTR 50480, and that's an even more interesting standard because that prescribes resistivity values that are corrected to temperature for different type of protective devices and where they actually sit. So whether it's a final circuit, what's the resistivity you take for the final circuit in consideration? What about the upstream distribution circuit? What resistivity do you take there? So that's more. That's more nuanced than just a 2/3 factor.
But it does kind of come back to the question of how different these characteristics are with their position in the system, where they're applied to design, and not all design or even design software probably will take some of that into account. It would be interesting to have a look at that.
I think I don't know. I believe in the UK there are two prominent design software. One is you have Trimble, and the other one is Electrical OM, right?
Electrical OM, yep.
So Electrical OM, I know, does this because a company that I have in India sells Electrical OM in the Indian market. So I had this chat before.
I think if I can just butt in there, Krish, I know you say we have Trimble and Electrical OM. We don't. We've just got Electrical OM because, well, we do have others, but let's be honest, there isn't anything that's more advanced than Electrical OM. I liken it to trying to drive the Starship Enterprise, and having to know everything. But honestly, I've actually sat down with one of my contractors once, living the rock and roll lifestyle on a Friday night, and we literally were getting the book out, looking at every single box that you tick and all the bits you wanted to understand it. And you're sitting there trying to learn it and teach it, and you're just like, oh dear Lord, have they changed? Because one of the biggest problems I have, and I don't have 50480, shame on me, is, and I'm gonna throw this question to John because I'm hoping he's got the same mindset as me. When I learnt, like when I trained as an electrician, I swear to God, every time I see something online where there's an influencer talking or some other manufacturer, it feels like we've created whole new ways of doing stuff. Or have we just learned from our errors? I mean, John, what do you think about this? Because I'm blown away.
Basics are the same, but yeah, there's the whole prevalence of just bung it in some software and the magic numbers come out at the end is definitely a problem. And if you just look at education as general, even like in like secondary school education of how they do maths and things, and now is totally different now. So a lot of stuff has changed. It gets to the same results, but the ways of doing it are significantly different. And then on the point of design, certainly in the domestic sector, there basically isn't any. It's 99% just slinging the old stuff that people have been doing forever. And this is kind of why you still see people putting in ring finals in 2-bedroom flats and other gubbins. So in the domestic sector, certainly, there is basically no design in a lot of cases. It's literally, oh, what we've been putting for the last 50 years, and we'll just carry on with doing the same. Even a new build is appalling for that. Hence, you've still got twin RCD boards going in and ring finals, one for the kitchen, one for upstairs, one for downstairs. And yeah, there's no thought been put into that for decades, basically.
Plus, obviously, with regulation changes, often changes equal more costs. So old designs stay there for longer than they should anyway, to avoid implementing new things and new technologies. I'm actually in 50480 now. I'm just browsing through some of these tables Chris has mentioned, to maximum short circuit current, circuits, upstream circuits. I've got some. I've got some homework to do.
Yes, you do, and that's another podcast for later in the year. Question then for you. Because the one thing that comes to my simple mind is, I think, John, you nailed it quite well there. I think there's lots of rules of thumb. We've always done it this way for 50 years. Why should we ever change? La da 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 da. So it's a question to each of you, and I'm going to ask Mr. Betteridge first. So I think it's fairly evident that most, I'm trying not to generalize here, a lot of domestic installers won't produce an electrical O&M design pack for Mrs. Jones's house. Is it okay to work to a rule of thumb? What are your thoughts, Mr. Betteridge?
No, I think CDM regulations come into things as well, and we should be designing from the outtake before we initially start any sort of installation work. It covers ourselves. Interestingly, with flats that I used to do, what I find a lot of problems with was if you did do a ring final circuit, you would put the cable in the wall, usually a stud wall with thermal insulation, and then it would derate that cable down to 13.5 amps in its reference method. So then it became a problem that you can't really have that ring on there unless it's touching the plasterboard, but how do you get it to touch the plasterboard throughout its run to dispense the heat? So there was problems I had seen in jobs that kind of lead to design problems. Then you end up having to go to the sort of like thermal conductivity of the insulation inside to see if it actually was that 0.004 WMH, I think it was something like that rating. So there are definitely implications and problems of people doing rule of thumb.
And I mean, Dave's right, because another thing that I see a lot, because I've been seeing a lot of apprentices in new builds, is the cables go through, but then when they're running down void spaces in walls and stuff, they just tie all the cables together. They'll tie all the cables together in huge bunches, and they'll be running like that throughout all the runs. And you can pretty much guarantee that those twin and ZPCs we're just getting away with it with our load characteristics, and the ring final magic that happens. It will start, there will be times where, as we start having more division of installation, we break things down more. It's going to start catching us out, because there's an awful lot of grouping that I think is unplanned for, undesigned, which just gets signed off.
That's so. Two valid points from both the Davids. John, rule of thumb. Do you think you'd be producing an electrical O&M? I mean, you're not stupid, so, and I'm not saying everyone else is, by the way, but it's a really valid point. Yeah, go on, John.
I think
this.
The main point here is that certainly for domestic stuff, people need to actually start thinking about what they're putting in and why they're doing it, rather than, oh, this is a house, we'll just get that standard consuming unit we buy for 50 years, or well, maybe a couple of decades, and we'll just get this cable and that cable and stick it in because that's just what you've done. There's no thought in it anymore. And the thing, like you said, with the flats there, I mean, I was in a block of flats just last week. All the walls are stud walls with insulation in, and that includes the external walls. It's 100% timber frame. So all of the cables are going to be in the insulation somehow. not a single one is going to be touching the plasterboard. I can guarantee it. And yet, rings in the consumer unit, rings should go in the bin, quite honestly, because they've outlived their usefulness. I mean, they should have gone decades ago. But if you are going to put them in, you need to think about what you're doing, because when they were brought in sort of back in the 1940s, we didn't have insulated stud walls. We didn't have insulation, basically. And yet here we are 70 years later, and people are just stuffing them in completely different circumstances, totally oblivious to what the problems might actually be. And it's just, oh, we've always done it this way, so it probably works. And unfortunately, it does usually work because, of course, rings are very rarely loaded up to the full amount. So most of the time, no, the cables aren't going to get hot and melt. But of course, there's going to be those occasions where they do. So
it's a really good point, actually, because the wiring rigs hasn't really updated to advise against that. You know, when rings were introduced, yeah, you're right. We didn't have all these stud partition insulated walls, so we're not really adapting or updating as fast. Maybe, well, fast. My God, it's been decades. But yeah, there's some really interesting thoughts there, to be honest with you, because you're right. We've got a. I'm going to use an auditor's term here. We've got a major non-compliance in our industry, whereas we're not doing design. I mean, Section 132 of the wiring regs says, talks about design. But we're not doing it. We're doing the rule of thumb.
Even domestically, there are some very simple things that we could think about improving. I mean, in the college environment, we've always kind of told apprentices, this is going back into when I started over 15 years ago, we'd say that when you install a board, you put the largest device to the main switch, and then they get lower as you go away from the main switch. So you do the 40s, the 30s, the 16s, the 6s. But also we know now with our basically, we have more interactivity with manufacturers, really, to get more of the actual real information from them. We know that there's negligible impedance in the bus system, and we know that we can put them in any order. And if you look, for example, at someone like John's Instagram, even when he does his Wilex boards, and I refer this to learners in the classroom, and they go, really? I'll say, just look at his feed. You can see what he's doing. He's doing, he'll bunch the power for a room with the lights for those two, and then there'll be a spare. And then there'll be the next room with the power and lights. Then there's a spare. So spacing of the breakers. That's a simple thing that we can just do. But it's getting that information to Sparks and just starting us to think about improving the design for even the basic stuff like that. We're still not doing that. So domestically, yeah. There are very different tiers of to whether design is done or is not. And there's very different
so
rounds for improvement, let's say.
I'm gonna say we've just opened the Pandora's box of the unwritten rules of domestic house bashing. I have an opinion on it, but I'll leave it till later. Krish, you had your hand up. You don't need to put your hand up, just chip in.
May I share my screen, Paul?
Oh, go for it. While you're doing that, has anybody seen the social media video that came out the other day where you've got a young electrician, and the young electrician walks into the wholesaler and he says, excuse me, can I have a 14-way board with type 2 surge protection? And then it flips to an old Spark who goes, gives a board, don't matter what, don't care what cheap is, nobody will care. And I actually resonated with the old boy going,
and the young lad saying, no, I need a fuse box for Instagram.
Yeah, it's just, and the old bloke don't care. Oh, do you know what? That's one of the few videos that I laughed a lot at.
I found that funny.
Anyway, sorry, Krish, I was just filling in while you were sharing your screen there.
No worries. So I've got these two lovely images courtesy of a company in the UK called Power AI Limited. And this is a brilliant image that shows what happens when you don't derate. This particular case was, there was a bunch of single core aluminum wired armored cables in a trench. And there was they did not take into account the grouping, and they had not taken into account the temperature inside the trench. So this is what had happened there. And this actually inspired me to make this table. And what this table is we have some rules of thumb in India. And the rules of thumb being, if you have a lighting circuit, you run it on a 1.5 square mil. If you have a socket circuit, you run it on a 2.5 square mil. If you have an air conditioning circuit, like a 1-ton air conditioning circuit, like maybe 3.5 kilowatts or so, you run it on a 2.5 square mil circuit. And for the lighting, you do a C10 breaker. For the air conditioning, you do a C16. And for the socket outlets, you do a B16. And where I live, it's very common to have ambient temperatures of up to 45 degrees. And it's also very common to have more than 4 circuits in one conduit. And which is, by the way, not compliant anyways, because you're now, sorry, go on.
So did you say more than 4 circuits in one conduit?
And I'll show you some images as well if you'd like.
Yeah, oh yes,
But,
please.
But there's a fundamental difference in the way contractors, I've seen at least the small time guys, erect conduit. Because I believe the right way of doing it is that you run the conduit first and then you fish the cables through. I don't know, is that done in the UK? But I know in domestics you don't use conduit in the UK.
Yes, you should be installing a cable management system, testing it, and then pulling in the cables, and then testing it.
There's a specific regulation that says that they shall only be installed in fully finished conduit systems. So we don't fabricate the conduit whilst the cables are in it.
So yeah, that's done in India. So the very office that I'm in right now, 5 years ago, when I had some electricians come in and put them in, I saw them putting the cable and then putting 1 2-meter bit of conduit, putting the wire in, just over it, right? And at the end of it, they got it all messed up, and I had to basically pull out everything myself, and not all the cables came out. So a lot of times I had to chop them up, and I had to basically rewire the whole thing myself. But anyways, what these tables are is they're trying to prove the thumb rule wrong. And whenever I present, we do one presentation across the country every 2 weeks. I show them this table and I say that no matter what you do, the thumb rule will always likely fail, because what I've done is the green cells mean it actually works. The yellow cells, I need to check the guide what the yellow cells mean. The red cells, they don't work for sure. And we have a problem because 4 circuits over 45 degrees always fails. And very often you need to be, either really low ambient temperatures, which is as close to the tabulated as you get, or really high or really low number of circuits grouped together. And I've done these tables for 4 factors. I've done these for 3 factors. I've done it for current carrying capacity. I've done these for voltage drop, and I've also done these for earth fault loop impedance. And I've shown that the thumb rule always fails. So call me crazy for it, but I really do believe that we can't use thumb rules in an age where installations are so dynamic and installations are so different. Like, I have 3 13-kilowatt water heaters in my house. I have 5 air conditioners, but I live in a 3-bedroom apartment. I don't live in a mansion. So it's like places are so dynamic, you can't use thumb rules. And especially, like John said, the thumb rules are made for really long ago, when we had completely different loads, completely different behavior profiles. Everything was different. So if you ask me, the thumb rule always fails. But that's my opinion here.
I don't disagree with you. Apologies, I've got a small dog sitting on my lap that just is being annoying while I'm recording this. But
do you sorry, Krish, do you design to? I mean, you mentioned 45 degrees. Is that mainly for outdoor installations? Is there assumptions that indoor installations are climatically controlled?
Sorry, I was muted. This is interesting because the standard, as you know, doesn't say anything about it, just like the British standard doesn't say anything about it. And unfortunately, we don't have any good guidance through the standard. But I actually personally calculate 45 degrees indoors because it's very common for a lot of installations to keep the windows open. Like, for example, if I run air conditioning all throughout the day in my house, it's too expensive. So I only run the air conditioning at night, or I keep a ceiling fan on the other times. Here in my office, I don't have a ceiling fan because the ceiling itself is too low. So here I run the air conditioning. So again, maybe I'm crazy, but I personally do my calcs at the maximum temperature, which is 45 degrees even for indoors. Outdoors is probably worse because of a concentration of sunlight sometimes. So if you actually measure the temperature, it's a lot higher.
Solar gain. Yeah, I mean, I have experience, obviously not in India, but I have experience in Dubai, with the municipality. There it's 45 degrees. And we'd often, when we do temporary power for things, we end up having to, the best way to get them out the sun is just to bury them in the sand and try to get the sun off of them, because when you have that climatic, that outside temperature, you're basically just running from aircon to aircon. But a lot of their systems over there are designed pretty much under 7671 because they are relying on the aircon really indoors. Externally, if you go to Dubai, you look out the windows, conduit systems, they've all kind of shrunk and retracted out of their luminaires. They've all reacted to the heat. An awful lot of systems over there just don't last long in those harsh temperatures outside.
Mr. Betteridge.
Yeah, interestingly, with ambient temperature correction, when you get to 10 degrees and below, it starts to actually get worse. So you actually start to lose capacity of your conductors in the flip and the other way around of thinking of it. With Krish, do you have to do the 1 plus 0.004 times ambient minus the resistivity temperature to get your correction? Because I believe it stops at like 30 in GM3, for example.
So yeah, we use that coefficient, but I don't actually believe that coefficient was designed for this. I think that coefficient comes from IC6. Oh, I need to check the standard number.
That's the copper coefficient, isn't it?
Yeah, so that's the copper coefficient from the standard for insulated conductors. So I don't actually think that standard that coefficient was designed for that temperature rise. Even though we do end up using it like that.
It does get abused to create factors. Yes, I do know that.
So I mean, yeah, Paul, this is what I was talking about earlier, and I know David, you've done Mr. Ninja, you've done a very good video on grouping factors in distribution boards. But this is a distribution board in a house, actually.
Ouch.
So, yeah, and this is this right here is the neutral bar, because there's no neutral bar, so they've just taken a big cable in there and they've taped all the incoming neutrals onto that. But yeah. So it's pretty crazy. My the favorite picture that I have actually is I need to find it, is a bunch of electricians crimping lugs. So they, instead of using crimping tools, they'd hammer the lugs onto the actual conductor. And I showed it to a friend of mine at the IT, and he couldn't stop laughing. And he still laughs today when I bring it up with him.
But it just shows the importance of having the right tools to use the equipment that you have. And I should imagine in some cases they just haven't got the right tools with them appointed on the jobs to use those lugs.
No,
I've seen
they don't.
Yeah, I mean, I've seen even in the northeast and the UK, I've got apprentices submitting evidence of them actually bending tube using trees and drains and all sorts of stupid things because they just don't have the actual bending machine on them.
It's pretty crazy.
John, my head's cooked. Wow, okay, there's a hell of a lot to consider in that. I don't disagree with you. I think one of the things you said, Krish, dynamic installations.
They're very dynamic. I mean, it's not like back in the day, what you have everybody had a light and a filament light bulb, maybe a heater, probably gas.
I was told 5 years ago at Alex that the IET were rewriting their maximum demand diversity and all loads of books. I think it was the electrical installation design guy. They were going to publish something new, but they were going to rewrite it to allow for this sort of stuff.
I last spoke to a gentleman who we actually just discussed yesterday about that at Bolton Alex 2 years ago, when I had a stand there. He came over, we had a good chat, and he's got an awful lot of books to write. He's got an awful lot of writing to do, but he said that there is work going on, and they're breaking it down to 3 sections. I can't remember exactly what he said, but it is being worked on, but it might be another 10 years away. The pace of that, because it's so, I mean, that's like the current stuff we have is just out of date for that kind of work.
Yeah, you could say it's out of date. The that thing it's been in the regs and it's in the guidance now, the thing about the the 66% loading for lighting circuits and all that that junk, that was introduced in 1934. So yeah, it's not just slightly out of date; it's over
Probably time for
90
it to-
years old. Yeah, it
It's
should have
probably
been
time to look
binned.
at it again, isn't it?
Yeah, it should have been binned like 50 years ago plus. And then you've
And
got the stuff about like 100 watts per light fitting and all that, which of course is nonsense with LEDs because nobody has it anymore. So
But the thing is, because that's in the books, that's in the classrooms. So the model examples that we have with the 2396 and stuff will use that resource. And I'll say to guys, well, no, just be more realistic. Use load management, make an assumption. It's like if I did design, I released a video today with a bit of design, and we just said, look, volt drop of 6.9 on a lighting circuit is only going to be a volt drop if you've got a really, 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 really long circuit, or you're pulling an awful lot of amps, which we're not anymore. So we can really sacrifice some of that in our designs. And but those adjustments aren't really considered in the courses and in the books. So there's not enough guidance because it just needs updating. Krish, obviously you came over to the UK to get your qualifications. I believe you did the 2396 and a couple of others. Was that because in India there aren't equivalents readily available or as popular or as recommended?
Well, the first problem is that not a lot of people know about our national standard for electrical installations. And
but you're obviously
because
working on improving, aren't you now?
Yes. I mean, I'm part of the committees that write the national standards for electrical installations, and also a couple of IEC committees. But so that's the first issue, right? And whenever you go online, because I speak English is my first language, so I'm going to get English results. So actually, recently I've been watching a lot of German electrical people. So ever since we've got AI, I can now translate in real time what they're saying. And it's some of the German electrical stuff is really good. I mean, so it's also all English, right? So whenever you search for anything, I remember as a kid, I searched for electrical installation stuff. I got on American stuff, and like they don't use the same voltage as us. They don't use the same frequency as us. They use different cables, so everything is different. So when you search online, actually, the first person's video I ever saw was actually Mr. Ward's videos. So I saw his videos, and I was like, "What's this BS7671 business?" Okay, rather, I think John, do you call it the wiring regs or do you call it BS7671?
it's called both. It was called one, and then it transferred. Originally, it wasn't the British standard, and then it was sort of converted into it over time. So, unfortunately, old names stick about, and officially it's BS7671, but it has other titles which people insist on using.
So I said, "What's this?" So then I bought the book, and it was expensive because I had to have it shipped over from the UK, and I started reading it, and then actually it was during COVID. I was a bit bored, so I think Mr. Watts, sorry, I should use the correct term, Mr. Ninja. I should. You made your 2382 videos free. So I watched those, and then I gave an online exam, and I got 100% on the exam.
Oh,
so I was pretty thrilled.
Course is too easy, Dave.
Yeah.
Now the course is extremely easy, the 2382. So
it really is.
So then it started from there, right? So then the reason I came over is there's not much knowledge of our national standard, which we're trying to change, and then I speak English. English is my first language, so it was extremely easy for me to come to the UK. I mean, I've been there on holiday twice before I started visiting for a couple-day electrical programs, and then it just went from there. What's next? And then after I did electrical design, the 2396, I figured that unless I want to spend a lot of money and a lot of time, there's nothing else more that I can do. And at that point, I discovered standardization. So I just started reading a lot of standards, and I bought the IT gold package, whatever that's called. So I had access to all the books, which for me, one of the best books has been the commentary on the wiring regulations. That is...
that's always very close to me. I think I've got that's actually just down there. That's a Paul Cook's book. I asked if that will be updated. Obviously, that's not an IET book, so they won't update it. Yeah, it's got IT on the front, but it's actually not the property of the IT as a publication. So it's
Paul
going.
Cook retired now.
Yeah, he's retired, and it's his book. It's not actually officially an IET book, hence they can't just version it to the 18th edition. And I've spoken obviously with Graham, going, when are you going to do that then? Because he refers to it a lot in the technicals, and I guess that's probably one of those work pieces he'll be doing on the side, because it's a really, really good book, and I bring it into all the design courses that I do, because it helps explain an awful lot of the limitations of 7671. It's a great book.
Yeah. One of my favorite chapters in that book is when it talks about metallic sheath cables, and it talks about calculation of sheath voltage on single core aluminum wired armored cables. And those calculations, I think, Mr. Betteridge, you would really like those. Have you seen those before?
Not with the aluminium, no. I've not tried them before.
So yeah, there's it gets really, really, really interesting there. And then, but at that point, if you do the calculations manually, it's purely academic. I mean, at that point, you need highly specialized software to do the calculations. If you're doing an actual job, otherwise you're not going to make any actual money. But
yeah, but that's one of the benefits of those skills, to actually just use software and verify that you're using it correctly. It's like when we do the design course, we look at the rating factors, and we look at the reactants, and we look at even like if you're over 60 mil, then you're doing sine and cosine for volts drop. A lot of electricians don't think about that, and if they don't have those inputs into the software that's correct, the software does an awful lot of assumptions. Basically it puts everything as one, because we haven't thought about having that input. And there are many inputs that we don't put in because we haven't got the wider knowledge of putting them in. The design does the magic, but it can only work with what you put into it. And that's, again, really, and I say it's really what the design course is about. It's not so much about, oh, do I need software? Not, yes, you need software. No one's going to ask you to do design in reality for all those circuits at that pace that software can do. But you've got to understand the inputs to understand it using the outputs.
So I'm going to sound really grey and grumpy and old, but when I did my 2400, good old days, software was available, but it was heresy to even suggest using it first. So you had to do the good old-fashioned pen and paper, design the circuits for, I think it was a shed manufacturing, like barn sort of thing, design course, and you had to design all the submains, all the boards, etc. Consider RCD protection, external environments, all that sort of good stuff, dust areas. But you had to do it by hand. And then there was a few people on the course who had companies that were rich, and they then used software to validate it. So we're now in a world where everyone just uses software without actually being able to design it in their head.
Well, that's what we try to fix with the 2496. They have to do a few of them by hand. They have to do a ring, a light, a distribution circuit by hand to show that they can do it. But when they're doing the project, there's probably like 30, 40 circuits. So we do a couple and then push the rest through software. But I mean, that's really what the course is about. It's just making sure you can use the software properly and identify those inputs.
You're actually allowed to use software like Electrical OM on the 2396.
I let them produce the project with it, as long as before they produce the project with it, they must provide, first of all, if obviously, like right now we've got a project that includes one of them is a rental area where you've got a business suite where you've got just rooms for rent or business for business kind of thing. So the lighting, the distribution circuit and the power circuit, and then the circuit to one of the PC workstations, will ask for them to be done by hand. So, you can type it, but just basically done manually, all the way up across to the final point with maximum verification of volt drop and the thermal withstand capabilities. Then once we know that that's done, they can then produce the rest through that. They'll do like a spreadsheet, and they'll put it on a spreadsheet. Yeah. That's the best way. But that can take forever. And you get 40 hours approximately. If you use software to then do drawings and CAD and stuff, then I'm not going to say no, because I'm going to say, great, here's an opportunity for me to then offer you some feedback on the way you're using those resources. But it's not paramount that you must produce that for me to pass the project. If you pass, I'll pass the project with a few manually done and then just a spreadsheet of all the actual manually typed in calculations. That's absolutely fine.
So
So interesting.
Someone tell me I'm not going bonkers here. So, in the good old days, when I did my 2400, a lot of stuff was resistive and inductive, and you had to manually do your calcs. And now what we're saying is there's so much dynamicness in electrical installation design that it's pretty much almost impossible to consider every variable without using some sort of software to assist you.
Correct.
Go on.
Sorry, first.
Correct, but they don't ask them to manually produce all these complex bits. Really, they still manually are just wanting volt drop, impedance. I mean, to be fair, the 2396, in the questions of the 2396 exam, they still haven't ever really gone down the territory of reactance. It's the large-scale EV course that's introduced the need to use reactance due to the large power demands of these cables, and they're being, they're significantly large in size. And when we're talking about, 2 times 240 mil parallels to feed, a per phase DC system. So you have the DC side, you have the AC side. We have significant concerns of reactance on the AC. We also consider reactance on the DC if it's got load management that will change the loads significantly, a significant amount of times. Then we have to consider reactance on the DC as well. So really, the large-scale EV has brought more of a reactance necessity, while the 2396 is still socket circuit, light circuit, lift. It's not as challenging.
Do we consider like dynamic? The dynamic impacts to DC circuits on PV, where 1 minute the sun's out, you've got a 100 kilowatt system going hell for leather, next thing, boom, big cloud.
Well, it's more about the rate of change at that point, I would have thought, unless you've got like no sun because a huge kind of jumbo jet has took the sun out and then suddenly it appears again, and that's happening regularly very fast. I don't think that's going to be much of an issue.
No, it won't.
Normally we've got and we've got daylight there as well. But obviously with DC of large scale EV, with load shedding and load management, it could, you could have someone plug in and then the battery system on the car could go down, up and down, up and down, up. And that could just be, significant shunts in the amount of power as it manages itself to the vehicles and the vehicles demanding of power. So normally we just say DC wouldn't be too much of a concern, but with large scale EV, it's a consideration.
Okay, you're making me feel better and making me feel worse in one podcast, which is a miracle in itself. So while I feel spectacularly stupid, I have hope that I won't be stupid once I spend 6 months camped in Middlesbrough doing lots of your training courses.
All you got to do, mate, is grab the IT design guide, read the back of it, get the IT code of practice, read Appendix M.
All them.
That's it, really.
Yeah.
And just actually, have a crack at it. There's a model example in Appendix M. I think it's Appendix M, or N. One of them. It's one with all the tables in the back.
Krish, unless you've got loads more, I'm going to ask some final questions and then go around and do some summaries. Do you have any more wonderful curveballs of where design is and where it's going to be you want to hit us with?
I mean, I've got plenty. I mean, one of my
Just go for it.
Favorite,
Keep going.
One of my favorite things is in the UK, right? You have a very easy way to calculate voltage drop. It's so easy that the cosines only come in on larger cables with power factor correction and stuff like that. So I'll show you on my screen how we do it in India. This is how we do. This is how we're supposed to do voltage drop in India.
Okay.
And frankly, I think it's highly impractical because you can't expect an electrician to do voltage drop this way.
So what have we done here? We've taken millivolt per amp meters and completely torn it to shreds.
Let's not adopt this version.
I can see the reactance.
So
yeah. IB.
So
IB.
Yeah, so let's make it really simple, and let's remove the IB because that's the same, right?
I knew that.
And let's remove the length because that's the same as well. So multiply by length, multiply by design. So that's the same. But then the interesting bit is there is a row 1, which is the resistivity of the conductors at normal service temperature. Instead of, because I think David Betteridge, Mr. Betteridge, you want to say something?
Yeah, I was just going to add that the millivolt per amp per meter is just basically resistance times 1.2. So it's
yes.
it is basically resistivity in a way if you divide the resistance. So if you add 44 millivolts per amp per meter divided by 1.2 and halved it, you would get that resistance. But obviously, you would need the cos and sin for it.
Yeah, you
Reactance.
need that as well. But that doesn't so beyond 16 square mil, you've then got R, X, and Z values in BS7671, right?
Yeah.
So it's very similar to that. And then also because in the IEC standard and in the Indian standard, we don't have those voltage drop values. So for us to calculate resistivity, we have to actually do ρ1 multiplied by ρ1 divided by S. So the larger the cable, the smaller the resistance. So ρ1 divided by S is essentially the X value that you have in BS7671. So there's that, and there's the cosine.
It seems to be a rather overly complex. I love the wiring regs version.
So, exactly. So I love the wiring regs version also.
Okay.
But the issue there, Paul, is that when you are in a country like India, you may not have access to manufacturers that actually compute these values for you.
Yeah, true.
And that's where something like this becomes useful. But we can't expect electricians to do this.
Well, yeah. This is what worries me, but I'll get onto that at the end.
Yeah. So I mean, we have a version, obviously the normal volt drop formula that we're typically aware of. You can see in 767 there is a underneath it one that has the sine and the cosine where we add them, but it's definitely not as complex as that.
No, it's definitely not as complex. And this is what I was talking about earlier also. Paul, I'm taking the liberty to share my screen. I hope that's okay.
Please do.
So
design chats are never short.
So this is what we were talking about, the limiting temperatures, right? So we have the basic Ohm's law, which is Z into I is equal to V. So V is equal to IR, right? And this is the interesting bit because this is how it's broken down. So in the UK, this is the formula that you follow, yes?
Yeah.
Yep.
And then sometimes you take a 0.8 to correct from ambient temperature of 30 degrees or whatever it may be to 70 degrees. But in a lot of other countries, we take 2/3 actually it depends because as you saw in that table in 5480, there are different resistance values. But in IEC, we like to say 2/3. And again, it's quite funny because, Paul, it's not just BSI that's not taking those annexes. Most countries don't take the annexes because they have their own way of doing it. So voltage drop, that massively complex formula is actually in the IEC standard, but nobody other than I think India takes that. So this is how it is, right? So everywhere has a different way of doing this. In India, we just like to say 2/3 because that takes it. We don't consider C min, we don't consider 0.8, and the actual reason is it's the correct limiting temperature, but nobody really talks about that. So to explain it to somebody, we just say, oh, it's a safety factor.
Yeah.
And if you ask me, I'm not okay with that kind of rule of thumb because sometimes it'll lead to wastage of material. But in a house, I think that's acceptable. Sorry, go on.
So this is Sunday night maths. That's just 0.6, right?
0.67.
0.67.
Yeah.
Right. So yeah. So it's a worse case in that
Yes,
sense.
it's a worse case. Yes.
Yeah.
Can I ask a dumb question? So you've got ZS is the impedance of the fault loop, and ZSM is the measured fault loop impedance. Is one the design and one the actual? Or am I being really thick?
So now this is where it gets interesting because I have deliberately used ZSM because the IC standard only talks about the 2/3 value with regards to ZSM. Right. In India, we don't we very nicely remove the M. Right. And we say that ZS design times IA has to be lesser than UO times 2/3. And that's because we have to take into account our conditions here and the fact that everything is not perfect and has developed.
So is that kind of like a temporary consideration, or is that something that is going to stick? Or do you think that they may change it?
So the standard currently reads something along the lines of, if your ZS exceeds this value, then further consideration is required.
Okay.
I was not involved in drafting that way. If it was up to me, I'd talk about resistances and reactances in an annex, but I realized that not everybody wants to have that chat.
Hmm.
You know, so because the other day we had I was at an exhibition and there was a guy with Type B RCDs, and we had a guy come from a DNO, and he was like, "Why is this so expensive?" It's the same thing as a Type. They're both RCDs, you know, they look the same.
Yeah, they're both
So-
RCDs.
So not everybody wants to have that discussion. So we just like to say 2/3 anyways. But it gets more and more interesting. Sorry, I don't mean to hog too much and say too much.
No. This is, I think, if I may interject, I think this is the first level 4 podcast we've ever done.
Well, let's produce
This
some
is
handouts
certainly
then,
a
won't we?
level 4. So apologies to everyone listening. This is not your level 2 or your level 3. This is certainly a level 4 podcast, because there is stuff in here that I'm just sitting going, I need to go back to college. Wow. This is weird, this trade. You're just constantly having to learn.
That's what I like about this industry, because
Yeah,
you're
that's true.
you're never at a point where you're like, I know it all. Because even the
That's
IC
true.
experts, they'll all admit that this is my area of expertise and I know it to this level. And that's what I find so interesting.
But let's not forget, it is just 3 wires.
Well, so this is the calculation on the screen that I thought Mr. Betteridge would really like, because it involves logarithms and a lot of square roots and a lot of other things. So this is to calculate sheath voltage in aluminum wired armored cables, where you have only one end that's connected to an earthing to protect, as used as connected to the protective conductor. So,
Wow.
and I really like to make presentations on this sort of thing, but as you can see, I had to, when I present these, I don't actually present these, because the people I'm presenting for say that if you present this, then everybody will just walk away.
We'll just leave. I have seen that before on a
Yeah.
City and Guild webinar before. What is just for our listeners? What is a sheath voltage?
It's basic, and again, I don't do work in this area much, so I'm going to tell you what my understanding is, and I know people may laugh at me for this, but what I believe is it's the voltage that's induced on the sheet as a result of all the other cables.
Right. So it's so you have inductive reactance that's happening from the load in the cable, creating a voltage in the sheathing of the cable. A reactance effect.
Right.
Is that what we're saying?
You thinking like capacitive coupling?
Yes. That's what.
So yeah, you have capacitive reactance and inductive reactance. We have 2 forms of reactance. It depends, obviously, the arrangement. Long loads parallel together, we have capacitive reactive components. Large switching inductive loads, we have inductive reactance. We have cause and effect. So the illustration there was a number of ones connected. So they're all in parallel arrangement. Is that correct? And they're all connected at the end.
Yes, that's
and that's to try to kind of bottle all their voltages together.
No. I think the idea there, and I'll have to get a recap on it, because I haven't actually ever presented this in public, because the person I was presenting for said that this is ridiculous. And I looked it up there. I looked it up then.
Yeah.
I don't remember now, but basically what it is that when you have multiple parallel runs of aluminum wired armored cable, is a choice as to whether you want to connect it to protective earthing arrangement at one side or on both sides. And there's a trade-off. And the trade-off is, if you do it on one side, you're concerned about the sheath voltage. And if you do it on both sides, then I think you get a lower current carrying capacity.
Okay.
So again, like I said, I don't remember. Like I said, we haven't. I just messaged Paul two days ago and said this. So I'm not well prepared, and this is not normally how I am. But
This is it's. I noticed that's from the IT design guide, so I'm aware of roughly where that is in the book, and that's my second bit of homework.
Actually,
I
I
want to look at
think
that.
that might be the incorrect reference. This is in the commentary on the wiring regs, but I actually took this from an IEC
I'm
standard.
sure there's sheaf voltages mentioned in the IT design guide as well. Let me look.
Well, I'm going to interject because people are going to crash their vans listening to this or fall asleep behind the wheel. A little bit heavy. I'm loving the sheaf voltages stuff. And trust me, there are people I want. Do you know what the worst thing is? There are people I've worked with who 20 years ago were talking about sheaf voltages and capacitive coupling and all sorts of stuff, and were sitting on EMC standard committees and had rules of thumb for, length of cables in parallel and various other. All this information's been lost, and I can't find it in any of the EMC standards anymore because they've gone from good old-fashioned descriptive to prescriptive, and we've lost loads of knowledge. But I'm sure we'll be able to find it one day. I love what you're talking about, Krish, because you're kind of taking old theories to new theories, trying to look at the logic, the reasoning, how you explain that, what formulas will work to validate your assumptions and your theories and the work that others have done. So that is a good thing. I do think, I'm going to say it out loud, I think electrical installation is getting absolutely bonkers because we are running at 1,000 miles an hour. There's so much to do. There's so much to think about. I mean, I was just thinking this. I was just writing out some post-it notes while you guys were talking. So we've got rules of thumb, which used to be a good thing, now potentially is dangerous. We've got an industry that should design, but really doesn't actually design. We've got dynamic installations, which really reinforces the need to design, including, as you rightly said, Krish and John, domestic installations. We've now got installations that rely on load management, that rely on surge protection, rely on diverted neutrals, broken pens, for leakage, unprotected conductor currents, new ways of looking at volt drop. Where the hell is the future going?
Well, I'll just quickly answer my bit. That is in the IT design guide under D4. I found that because I remember seeing that. I think the thing is, back in college, we cover in science and principles. We mentioned in level 2 science and principles what capacitance is, what inductance is, what the two of them combined. We deduct the largest from the lowest from the largest, and we end up with impedance with our triangles and SOHCAHTOA and everything. We repeat that in level 3, and a lot of it gets left at college, and then we just put in systems, and we've got a legacy of just cables, impedances, full currents, disconnection. And as we've said on a few recently, we're going into technologist territory where a lot of equipment is a lot more sensitive to reactance, to leakage currents, protective conductor currents, sheath voltages, all these things. And it's, again, as technology and equipment gets smarter, it's going to start playing with the behaviors that maybe we haven't been using as much in the field, and we're going to start having to be a lot more conscious to things like these reactances, whether they be capacitive or inductive. I just think that's just the evolution of this trade.
What is that on the screen?
So this is in response to what Mr. John Ward was saying about domestic consumer units. This is my home's distribution board.
See, in the UK, something of that size, every electrician would just go, no, they just moan. They just wouldn't expect something. But, how many properties is this for?
This is just 1 3-bedroom house.
That's 1 3-bedroom house?
Yeah, and the electrician that I hired to do this ran away in between once.
Okay.
But the reason he ran away was because when he did the bends in steel conduit, I was not happy with the fact that instead of doing double sets, he offset the bends off the wall with unistrut.
Oh, wow, okay.
So I was very unhappy with this, and I gave him a big firing, and then he ran away. But
so are you asking us to snag your board? It's like raid my board.
No. I
Okay.
just want to. The reason I brought it up was like John was saying about two RCD consumer units. So I've actually got Type Fs and Type Bs here, and I've got
Ooh.
AFDDs as well. But it was I ended up spending about $5,000 on this in British pounds. So I only did it because it was
Yikes.
fun for me. But
for you.
yeah,
The future of domestic fuse boards, eh? Three phase, Type F, Type B. Do you know what though, Chris? You're not wrong, because a lot of new modern fuse boards realistically should have Type Fs, Type Bs. They should be. I'm seeing a very clear and present danger in the form of gaps, and that using of rule of thumbs. How many more decades are we going to be able to wing that?
And it seems like the manufacturers always just try and hold it to the minimum that they think we need each time. I saw your post online earlier about Type C, 500 milliamp, you
Yeah.
know, and they're going to apply Guy. That's a bit steep in it, but you're looking ahead. You know,
I have a feeling that when I'm 65, the IET are going to announce everything should be Type B. Chuck all your Type A's in the bin, and I'm going to sit there and go, "What did we tell you, boys? 20 odd years ago, we told them."
Yeah.
It's just, yeah, we're not for a dynamic industry that moves as and when it wants to, especially when money's involved, and for a dynamic load profile that's being created by new technologies that's ever constantly changing, we're as slow as hell. And we need to be fast.
The problem is there's an awful lot of agreement that we want to make money, so let's just put in the minimum now, then in 5 years we'll do it again, then we'll do it again. Everyone buys, everyone sells, everyone has a go. But the question or the concern I have is when we're not putting equipment now that we need to put in now to protect people because it might not yet be available. That's my concern.
Krish?
I just wanted to add in there in defense of all the guys in standardization, and I only say this because I'm also in standardization. It's very hard to build consensus on an IC level for subjects like this. And that's why they don't trickle down to the national level. And the other side of it, looking at it, is that yes, national committees can obviously depart from what it says on the IEC standard, but then that's not international standardization anymore, is it? So there are two sides of the coin. One side of the coin is that the standards aren't picking up with the industry, and I'm not saying that that's wrong, but I'm also saying that it's really hard to build consensus, and that's where it comes into people like you guys, or Paul, what you've been doing, right? You've been talking about what people need to do, because I'm borrowing this from some guys at the IT who say this, but standards are the minimum requirement. And
we've been saying that a lot longer than the IET have, trust me.
So yeah, if you say that too, then that's
I'm
great.
I'm gonna go out on a limb here, and I don't care if they get upset, but there's a lot of narrative that comes out of the IET that we were spewing into them 5 years ago, as was Mr. Skirm. And it's great that they're now on board, because that's the message that needs to go out in a manner that is simple for the layman to communicate to. So absolutely, standards are the minimum. They're not something that you argue over. They're the thing you work from. 100%.
Yeah.
But
So
I can see
it's really important. Yeah, sorry, go on.
Yeah, no, I just say I can see though why on an international level it takes a lot longer for things to appear. You know, I can definitely see why, you know, at the IEC international level why it will take longer for changes to be agreed and standardized. That's definitely understandable.
Could they
Yeah, I mean,
possibly? Sorry, go on.
So no, I just wanted to say that, like, for example, in the UK, you say that Type AC shall be used only for fixed loads, blah 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 blah. That's not in the IEC standard yet.
Yeah, don't. It's a load. That's a load. Forgive. This is where the swear word. That's a load of bollocks. We're just we just ain't got the balls to ban Type AC like most sensible people around Europe have. This is just someone being super clinical. Well, there could be a purely resistive load where it still could be potentially. Oh, grow up! Come on.
It does serve an interesting point that if the international standard doesn't take a change, and we don't see the change in our standard, but we see the change in a neighbor standard, such as who we were looking at with ACRC, was it Denmark or Germany, where they were just banned from domestic properties and so forth?
Germany, for example.
You know, I mean, we need to take. You know, are we going to learn from them, and we're going to think about that to work better than our standards? I think that's, you know.
Yeah, Krish, you wanted to say something?
No, I was that's all I was saying. That yeah, I mean, I was just saying, yeah, that's why it's important to have people like yourself, like the three of you guys, right? And when Mr. Scrum was there before, you guys were talking about beyond the standards and what needs to be there. And I think it's really important for the industry to have people like you yourselves that talk about going beyond the standards, because at the end of the day, that's, I mean, the standards is a minimum requirement. Yeah, that's all I was saying. Yeah.
Krish, if I can clarify, so in BS0, the standards always mention that a standard is a consensus of expert, an agreement of a group. Like with politics, basically, they may not all agree, but if they agree on a principle, then that's what forms the minimum rules of engagement. It's the same with standards. It's a consensus of experts. My problem is one of the reasons why we still do these is, I'm going to quote a wrestler called CM Punk, a voice for the voiceless. You need to have independent voices that are not manipulated by the old pound notes. And the one thing that I have learnt and have seen in my career, our industry consensus can easily be achieved by the friendship club that sits on some of the committees. We don't do friendship club, we do fact club, and facts don't care about feelings. We're happy to be told we're wrong, happy to learn, happy to go on a journey. But Dave, you know, for at least 5+ years now, even, well, more than that, we've had some pretty powerful predictions that have come pretty bloody true. So yeah, I'm going to kind of draw this to an end, but I want to start off with kind of like, I want to ask each one of you. I'm going to start with Mr. Betteridge. Where do you think the future of design is going to be in 5 years and 20 years? Where do you think it's going to be, mate?
Probably in the hands of AI, in the future, how it's going. Everybody
Exactly
seems
my
to like
thoughts.
to AI answer most things, and there is design software, I believe, that's using AI at the moment to help itself, especially in the CAD world. I hope it don't. I hope we still maintain the level of knowledge manually, even though we got this great software. We still need to check it's correct.
Yes.
One thing on my 2396 with Dave, as probably remembers, a CT correction calculation that's applied to the volts drop on mine, and then me realizing at the end I have to recalculate everything to make sure that this is actually correct, which is good to have that kind of underpinning knowledge. I don't always trust software, and you also have to remember the user can be at error putting certain things in, like power factors, for example, for unresisted loads and banging it in as a 1 power factor unity. So yeah, in the future, we got to be careful.
I'm going to take it back to the big man, the governor himself, Mr. Ward. What's your thoughts on that?
Well, in terms of design, I mean, certainly domestic, first of all, at the moment, so there is little to no design in domestic, and that has got to change. And there's all kinds of stuff which is not considered in domestic currently, which already needs to be, things like power factor, because even like 20 years ago, everything in domestic property was basically unity power factor because it was incandescent lights, heating, and even electronic stuff had linear power supplies. But now it's all LED lighting, it's all electronics for switching power supplies. So we're already there, and none of this stuff's being considered, and we're just slinging stuff in as if it's 1960 or something. So yeah, we need to start considering all this stuff, and it's pretty much too late because we should have been doing this like 15, 20 years ago. So yeah, power factor, what kind of loads you're putting in, and all things like the sort of leakage current you're going to get from all this equipment, which is already causing problems with things like RCDs, whatever. So yeah, we're way behind in that particular sector. So yeah, start catching up.
It's interesting because all my brain is telling me is this is going to drive costs up, which means less people are going to want things rewired because of the design implications and the cost of it, which means there's going to be more accidents, incidents, and fires from life expired equipment. And we have the other elephant in the bloody room, and that is how many people are competent and qualified to do design nowadays. Because Mr. Betteridge, me and you have had lots of chats offline. It's like finding the next unicorn. There's very few that can do it, and trust me, I've met a lot, especially in my job in rail, that say, yeah, I'm a designer, and they're not. They're just someone who can use CAD, who knows how to plug some numbers into electrical OM, and when you then start asking them, what does that mean? How they've derated this? Perfect example. We had a railway station where the roof, it was a glazed roof, 50 degrees ambient temperature. 50 degrees, and it was set at 30 in the design calc. Then uprated to 50, boom, cables a lot bigger. And Krish, you're sharing something on the screen because you want to talk about it.
I'm sorry again. I may come off as impolite. I hope that's not the case.
No, this is perfect. You just do what you need to do. This is how we
Do
do
what
this.
you do, man. We wing this. Yeah. Come on.
So you said something very interesting about cost, and maybe I come from a place of privilege, so I can say this, but I like to view things as you can't have all three. You can't have usable, safe, and cheap.
Yep.
You can have an installation that's usable and safe, and that's where we need to be. You can have an installation that's usable and cheap. That's most installations in my country. You can also have an installation that's safe and cheap, but it's not going to be usable. If you take an entire industrial building and put it on a single type B RCD, the moment you turn something on, it's going to trip, and that's it. You've got a perfectly safe and cheap installation that's unusable. So I like to say that you can't have all three. And it's just the reality of it. But yes, as when I talk to clients, that's what I try to explain to them.
Oh, that's really good.
Yeah.
So I'm assuming your goal is in 20 years' time that design in India is going to become more and more prevalent and all the rest of it. What's your views on that before we finish up?
I think for me, the aim would be that people, I don't even look. I'd say I'd be very ambitious if I say that that design becomes more prevalent and correct design, because design is done on larger sites, but correct design is done. I mean, like I have a company that sells electrical OM in India. If I get a lot of users for electrical OM, I might make a lot of money on it, but that doesn't necessarily mean that design is getting a lot better. What I'd hope is that people appreciate how dangerous electricity actually is. I hope that happens. And when that happens, there's a natural progression, right? I mean, if you're afraid of fire, you don't touch fire. If you're afraid of electricity, then you make decisions such that you choose a safer solution. And I get a lot of crap for saying this. I think a lot of safety is binary. It's either safe or it's not safe. What is considered safe is a matter of consensus. But at least when you have a consensus for what is safe, at least among certain people, it's quite binary as to what is safe and not safe.
Fair enough.
So what do I want? I want people to appreciate how dangerous electricity can be. I remember I went to a client a couple years ago and they awarded me the job. And at the end, they said that, you know what, we're awarding you this job, but I don't actually believe electricity is dangerous at all. And that just like, my heart sank when he said that.
My response would have been unzip your flies, get your love spuds out. I'll stick a wire in them and you tell me if it's dangerous or not. he'd soon shut up if you put 240 volts across his love spuds. You'd probably be in prison for it, but those sorts of people are ignorant, and only a good old-fashioned slap will get it out of them, to be perfectly frank, because I've no time for those idiots. But anyway, right, moving on. Mr. Watts, last. Future of design. Talk to me.
Well, I agree with Mr. Betteridge. AI is going to get, or if it's not already being ingrained into this process, which I think is going to actually probably have a negative effect. We've got, say, for example, the domestic apprenticeship right now, which is the new apprenticeship. As John said, with power factor and all this stuff, which is very much part of an active domestic installation, has been for many years. The new apprenticeship is still based upon, this is a socket circuit, this is a ring circuit, this is a cable type, this is an installation method. It doesn't really push hard in that space. And we need to work on that bit as well. We need to identify what electricians need to actually be able to do, but not obviously, without jumping on my soapbox with training, unless we can get that kind of done where electricians can receive that development and actually maintain the development, we're going to struggle for designers to be able to carry on designing straight from qualifying. And by all means, a 2396 or similar can help, but a lot of times people will go, yeah, we've done that, but then they'll rely on third parties. I mean, I've just done a training course this last week for one of the biggest building companies in the UK for the large scale EV, and the guys all came onto the course. I got great feedback. They were really, 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 really fond of the experience, but they were like, and I was saying to them, you need to keep using this. You need to maintain this. Your employer needs to support you, because really they've been desensitized with blanket health and safety. And a lot of all their designs they do are actually out, they're actually done by a company in India. They send the design and a company in India sends the designs back, And so they were looking at them and looking, oh, okay, we can play with this, we can play with this. But they need to do some of it actively themselves as well. And if we don't get involved in it, or at least read them and review them, those skills won't be there. So yeah, I think in the long term, designs will get a bit more complex. Software will get more clever. But I just hope we can still maintain control of it instead of having so much guesswork with AI. That does concern me.
Oh, sorry, I agree with you. We're going down the world of AI. I think that's going to happen. It's quite a scary thing. I have an idea, but I'm going to do it offline. I have an idea of that, but I will not put it on this podcast because somebody will nick the idea, and I think it's quite a good one. Yeah, guys and girls, I'm going to end it there. For those of you who are watching or listening, this has been Bingo Calling with E5, also known as Design. Boy, oh boy, do I need to level up.
I've really enjoyed this one.
I feel so stupid and inadequate. It's mind-blowing. But that's the good thing about knowing your own limitations and surround yourself with people who you respect and like and you can appreciate and learn from. It's the circle of life. We'll end it here. This is our record-breaking podcast. I think this, other than webinars, this is the longest one we've ever done, which is great. I don't know when this will be out, a couple of weeks, probably, Krish. But thank you very much for coming on. You're more than welcome to come back on any time at 3 a.m. India time. Mr. Betteridge, you'll be back on at some point again, no doubt. JW and Dave, thank you very much. And to everyone watching and listening, take care of yourself and each other. Bye-bye.
Bye-bye. Bye.
Bye.
All right. And then that's...